Welcome everyone, and thank you for attending. We appreciate it. As you know, today's presentation is going to be all about ESD wrist straps. So I'll get started. Click on my presentation here. Okay, my name is Greg Heckler, and I'm your presenter today. I'm the Western Regional Sales Manager. I'm an ESD certified technician, and I've got 39 years of experience in ESD control. Jeffrey Brake is our organizer, and he's also our Desco brand manager. So in the middle of the presentation, or a few slides in, we're gonna take some time to answer some of your questions. So if you would just type them in throughout the presentation, we'll get to those during the middle of the presentation, and we can answer more questions at the end of the presentation as well. So what is a wrist strap? Well, in a nutshell, a wrist strap is the most reliable method or way of grounding the human body. And the wrist strap, although we affectionately call it just one thing, the wrist strap, it's actually a conductive wristband and a cord, or a set, if you will. While you can purchase these components individually, we usually call a wrist strap both the cord and the band. Let's talk about what the ANSI ESD S20.20-2014 standard says with regard to grounding the human body in wrist straps. To begin with, it's one of the most important technical requirements. It accounts for a lot of the protection for your ESDS devices that you're going to get when you ground the human body. It keeps the human body at less than 100 volts, and that's what the whole standard is based upon. So it's very important to ground the human body, and the best way to do that is with a wrist strap. When you plug your wrist strap into that ground jack, or the place that you're plugging it into, that ground jack needs to be 1 ohm or less. So that's important. You see down here in the table, there's product qualification and there's compliance verification. In the case of both of these, whether you're qualifying it for an initial purchase or whether you're testing it after it's been installed, the test resistance needs to be less than 3.5 times 10 to the 7th, or less than 35 megohm. And that equates to that less than 100 volts. So if you're less than 35 megohm, you can't have more than 100 volts on your body. So other requirements of the standard. This is one of the most important ones as well. When you're seated, you must wear a wrist strap. And the reason for this is, if you look in the picture over here on the right with the gentleman here, the assembler here on the right, you see the foot with the chair ring. Many times people are apt to put their feet up on the chair ring. And if they do that and they're wearing foot grounders or an ESD floor, now they become ungrounded. So that's the #1 reason for having that rule. Also, people might just, be resting up on their tiptoes. And if you're wearing heel grounders, now you also become ungrounded. So that's the main reason why you want to wear a wrist strap while you're seated. The place that we ground that wrist strap jack to, or the preferred ground, is our equipment ground or our electrical AC ground. Now, another requirement is that you have to have daily compliance verification, or your wrist strap assembly in human body needs to be tested at least 1 time per day, and then a written test log is also required. Personal safety. This is a very common question that we get. The questions about the 1 megohm safety resistor. The standard requires that all personal grounding products, wrist straps and ESD foot grounders, contain a 1 megohm safety resistor. And that resistance will protect you up to 250 volts. The standard also recommends that you not ground the human body over 250 volts. So if you got a test application, let's say like a high pot test or other high voltage, you're working on energized equipment, we don't recommend that you ground the body. And if you have those, just contact us and we can give you recommendations how to protect your devices from static if I can't ground my body. Another requirement of the standard, and this goes back to the qualification procedure, when we're making wrist straps, one of the things that we need to adhere to when it comes to the cord and wristband is that we have to make these products that have a minimum of 1 foot-pounds of breakaway force and a maximum of 5. So you don't want less than 1 pound, otherwise the cord might just fall off band during normal movement. You don't want more than 5 pounds, because if you had to get up and run, fire or some other emergency, you want to be able to break that cord off your wristband so you can get away. So all of Desco products meet that breakaway force requirement. Also, all of our grounding products are UL listed. And so UL says they are safe for use designs. Now the picture on the bottom left is just a little screenshot of a tester. And as you know, I mean, many of you are testing your wrist straps now, probably periodically. You know that when you get a green light, that you're less than that 35 megohms. But if you get a high, that means that you've gone over that resistance number. And if you get a low, that's equally as important, because that means the body is now less than the 1 megohm upper or 1 megohm safety requirement. So it's important that if you get low, you have your employees let supervisor or somebody else know that. We'll take some questions now. Do we have some, Jeffrey?
Yeah, we got a few. Can you reiterate on the 250 volts why the protection is only up to 250?
Well, that goes to that 1 megohm number and that size of resistor. By the way, it's actually a little bit less resistance that will protect you up to 250 volts, but our industry has just standard on that 1 megohm value for many years. So you're well protected up to that 250. But you know, the higher voltage you go, you're going to need more resistance to keep the human body safe. It's just that the industry standardized on that 1 megohm many years ago.
And if you're working around higher voltage, that'd be a situation where you want to consider other, where you wouldn't want to wear wrist straps.
Exactly. You might want to, even with the resistor, you might want to consider a GFI circuit breaker or a GFI circuit interrupter for applications where high voltage. But without that, you know, you have the safety protection of the resistor.
Gotcha. There's a question about the, can you wear, what are situations where you'd be wearing foot grounders and wrist straps, or is that a possibility? Or can you explain the possibilities for that?
Yes, absolutely. Actually, wearing foot grounders and wrist straps is a good thing. Anytime you have redundant grounding, that's a good thing, whether it's electricity or, you know, standard AC electricity, or it's an ESD control. But the main reason you wear ESD footwear and have a conductive floor is for mobile personnel grounding, or grounding of carts, mobile carts, ESG chairs, things like that. So it doesn't hurt, or when you don't want to be tethered to a cord, for instance. So it doesn't hurt to wear both. But again, the reason for the rule is that when you're seated, there's more likelihood that you're going to remove your feet from the floor and become ungrounded.
Gotcha.
Okay.
Gotcha.
Anything
One
else?
other question. Yeah. Disinfecting and cleaning of wrist straps. Is there a standard or recommendation?
Well, there is no standard for it, and obviously this question is getting asked a lot lately in the last couple of months. We're getting asked a lot about cleaning ESD mats and things like that. And there are some advantages to Desco wrist straps, both in the cloth and the metal bands that I'm going to discuss. Our cloth bands could be laundered. You could wash them with soap and water and dry them and wear them again if you want. Our metal bands, what makes them nicer when it comes to any kind of disinfecting requirement is that they're all stainless steel. So they would be very easy to take and wipe down with a solution of 70% isopropyl or greater and water. So either way, you can launder our cloth bands, or you can easily wipe our metal bands down. Any other questions?
Yeah, one more. The cordless wrist strap, just before we go further. Can you comment a little bit on the cordless wrist strap?
Well, that product, maybe, I don't know, who knows who makes these things. Most of the stuff comes from offshore, but the cordless wrist strap concept or product has been out there for a while. But when you think of the concept of ground is basically hard. You need to be attached to earth, or you need to be attached to ground. So in order for the drain that static electricity off your body, it has to go to a lower potential. So if you're wearing a wrist strap that doesn't have a cord there is no lower potential. Basically, the way those things are made, they have some conductive fibers inside the buckle or the band of the cord that is the lower potential, but it's a capacitor. So the static charge might move away from your body, but it just goes onto the band. So cordless wrist straps really don't work. They don't dissipate the charge, and also the standard requires that you be grounded. So you'd be violating the standards requirement anyway. Anything else?
Okay, yeah, that's good
Okay,
for
we'll
now.
get moving.
Let's continue on here.
Okay, those are all good questions. Okay, wrist strap types. There are two primary types, what we call single wire and what we call dual wire. And basically, it's easy to tell the difference because a single wire wrist strap has one wire in the cord. Now, in the case of our cords, that's stranded wire, but it's a single conductor, if you will. Another good way to tell a single wire wrist strap and cord assembly is that single wire wrist strap and cords have banana plugs. And so that's probably the easiest way. They also have a single snap on the band. We use 4mm standard snaps on standard single wire wrist straps. And they come in both cloth or metal. And they're pretty much the standard that's been used since wrist straps were invented, or since, we helped create this process way back in the late 70s, early 80s. Dual wire wrist straps are designed to be used primarily or exclusively with dual wire monitors. So you wouldn't use a dual wire wrist strap and cord if you weren't using a dual wire monitor. Yeah, you could theoretically put a 3.5mm stereo jack on your workstation, but there's no need to do that. So the difference primarily is that dual wire is made and designed for use with dual wire continuous monitors. And you can ask more questions about that or later on if you'd like. What really sets us apart, whether it's wrist straps or foot grounders or other ESD materials, is that Desco makes about 85% of what we sell. We make them in our own factories, and we make all of our stuff here in the United States. And now when it comes to wrist straps, I'm going to talk about a few of the things that set us apart, what makes our products last so long. One of those, we use medical grade stainless. So it's a real high quality stainless. It won't corrode, it won't rust, makes excellent continuity with the human body. All of our products are date and lot coded. So there's traceability on our products, even something as simple as a foot grounder or wrist strap. We also stock product locally here in the United States, so you don't have to worry about long shipment times or delays coming from offshore. And we're the only company that actually makes a wrist strap in the United States. We make our personal grounding products in Southern California, and here's some pictures from our factory. Like this picture on the top left, that's the molding process. So when we assemble the cord, it goes into ejection molder, and that's what molds the head of the cord, and that's what it looks like here on the bottom right. This top right is our screw machine process. We make our own banana plugs. We machine our own snaps. So we're the only company that does that in the industry. Wristband performance, and this is where we really shine. On our cloth adjustable wristbands, which you can see over here on the right, it's an extra wide material. It's also knitted, so it's very comfortable, and it rarely ever stretches out. The cheap offshore bands that come from Asia and other places, those are narrower, they're thinner, and they tend to stretch out a lot. So you're typically having to tighten these down quite a bit. And if you were in as many places that we are, you'd see that all the time. Another feature that I really like of our adjustable band, which we actually invented many years ago, is that when you adjust it, the extra tab or material that you're pulling is underneath the buckle. So the extra material doesn't interfere with the swivel of the cord. So your cord will swivel 360 degrees, puts less strain on the strain relief, and is a lot more comfortable to use. One of the biggest advantages, though, to our cloth materials is that we use silver conductive threads, not stainless steel. So they're a natural antimicrobial, and they don't break down or fall apart like stainless steel fibers do. So if you're concerned about FOD, which I'm going to touch on a little bit more when I talk about cords, or if you just don't want conductive metal fibers on your circuit board or someplace else, our bands are the best for that application. We also have our parts are individually available. So you can buy the band only, you can buy the buckle only. So there's no need to throw high quality wrist strap like this away. You can just, for a couple of bucks, you can buy replacement band material only, or you could wash it like I said. There's two types of snap connections from the cord to the buckle. One is the machine 4mm snap, as I mentioned earlier, and then there's the mag snap connection. We're the first company to invent the magnetic snap, and I'm going to get into that a little bit more. But one of the things that also sets our 4mm snap apart is we machine that ourselves too. So that's how we consistently meet that 1 to 5 foot-pounds of breakaway force. More wristband performance are metal bands. These are the best wrist strap bands that you can buy anywhere. We have 3 different styles. We have the traditional wider style, like you see in the white one over here and the black one on the bottom. And then we have a new ultralight band. So you can see it's nice and thin. It's very lightweight. You know, some people don't like that thicker band on their body, so we made a new lightweight design. So we're the first at that. They're pinchless, if you will. You know, in the old days of the Spidell Twist Effects wristband, this is what they sold, is that they don't pinch the hair on your arm. And so that's what sets us apart as well. Another thing is that these links, or stainless steel links, they have an individual insulative cap on every link. We don't paint our bands. That's what the cheaper ones are made out of. They, you know, inferior quality stainless and painted metal. When we make this, when we make these straps, you'll see we've got a black one here. We got a white one here. We also have blue bands. The cap is actually clear, but the adhesive is the color. So hence the black or white or blue. But each individual link is insulative. And so you don't have to worry about FOD when it comes to these, because they don't chip, they don't fall off. And again, the metal's available in both 4mm snap and a mag snap. Now this one on the bottom left here, that's what we call our Mag Snap 360. And this is the first time that anyone's created a magnetic snap that will revolve 360 degrees. So this is gaining in popularity out there with those dual wire monitor users. Coil cord performance, the second half of the wrist strap assembly. And this is what takes the most abuse when it comes to the wrist strap assembly. We're constantly flexing these cords, pulling on them, tugging on them, unplugging them, plugging them. So they take a lot of abuse, which I'm going to get into. There's 2 cord materials that coil cords are made out of. The most common one is PVC, and this is easily distinguishable in the competition as well as our product, in that PVC cords are black. And one of the ways we market these products is by the retraction of the cord material. The PVC material is a much more relaxed retraction. So a lot of people like these because they don't pull on your body. You know, you're not feeling that retraction of that cord all the time on your wrist. So that's one of the things that's made them popular. However, a number of years ago, we also developed a polyurethane cord material, and that has a more snappy retraction. And so nice thing about those, especially with longer cords, is they're not going to drag on the ground. They're going to stay close to your body, if you will. But most importantly is when you combine polyurethane material with our patented strain relief designs, we can now warrant these strain reliefs for life, and we're the only ones that can do that. This cord on the bottom right, that's the Mag Snap 360 cord, and it's easily distinguishable because it has that blue head, and as you can see, it has that angled 3.5mm plug. And again, they're all UL listed. Well, the single wire designs are UL listed at this point. More coil cord performance. Here's a good picture of the Mag Snap in work or in use. One of the most important things about that, and the reason we created it, is in every traditional cord, what uses a regular 4mm snap or our machine 4mm snap, inside the head of the cord are two little parallel springs. And it's those springs that expand when you push it over your snap, and then they contract, and that's what holds the cord on the snap. Well, occasionally those springs will break, or at least one of them, and that's going to cause intermittent problems. And it's going to be particularly noticeable if you're using continuous monitors. So ours tend to last extremely long, but it does happen from time to time. So one of the best advantages of the MagSnap cord is there are no moving parts. So it eliminates all those intermittent problems. In fact, I had a customer that was having intermittent problems, and they've been using our MagSnap now for probably over 6 or 7 years without a single intermittent problem now. So either way, we make the best snaps on the market. Again, more coil cord performance. In the qualification process of a wrist strap and cord, one of the things the standard requires is that the strain relief of a cord needs to flex a minimum of 16,000 cycles. So what we do is we hang these cords in a motorized test fixture, and then the motor flexes that cord 45 degrees in both directions, and then we test them until they break. So they need to meet a minimum of 16,000 flex cycles. Our PVC cords go well into the over 1 million to roughly 3 million cycles, whereas the polyurethane cords were well over 65 million flex cycles now. There's no cord on the market that even comes close when it comes to flex cycles. And if you look on the right, another thing we created was we created the angled banana plug. One of the big advantages of that is that when you plug that into your ground jack, your continuous monitor, is your cord hangs straight down. So it puts much less strain on the strain relief, so they last even longer. Also, it forces you to pull the cord out by the plug instead of the employee just getting up and yanking it out. And that's what causes, especially on the cheap banana plugs, it causes a lot of those plugs to bend, and that's what causes you intermittent problems also. Here's a close-up shot of our banana assembly that we machine ourselves. If you look down at the bottom, the banana plug, you'll see that the shaft is convex. It's not straight like other banana plugs. And so when we snap this spring, it's an 8-part spring. When we snap it on the plug, because that's convex, the banana spring can't collapse beyond the point of return like the cheaper banana springs. So these rarely, I can't even remember the last time I've seen a broken Desco spring. So this also makes your banana plug fits more secure in the jack, causes less intermittent problems, and just makes them last much longer than any other product on the market. Cord lengths. We have multiple cord lengths in both the PVC and the polyurethane styles, from 6 feet all the way up to 25 feet standard. So whether you're just setting at a workstation or you're working around a big cabinet type of assembly, or we have customers that build satellites that need to, be standing on ladders and working around their product, we've got cords that, will meet just about any application you have out there. We also have extension cords too, so you can go, up over 40 feet if you wanted to. We don't see much of that, but it is possible. And what I really like about our cords too is that they actually stretch to their rating. Many of the offshore cords call themselves 6 feet, but they really don't stretch that far unless you really stretch it out. Desco cords easily stretch their length, if not more. Testing methods. As I mentioned, the standard requires that you test your wrist strap body assembly. And notice how I said body assembly. Remember that this is all about grounding the human body. So you're not just testing the wrist strap and cord, you're testing your body's resistance to ground. And you can do that in 2 ways, what we call periodic or continuous. So for those of you out there that are walking up every day and putting your banana plug in the tester and pressing the button and get a green light, that's what we call periodic. And you need to keep that written test log at least 1 time per day. We also have an advanced periodic test equipment with data acquisition, this picture on the top right. So now you can periodic test, but automatically record that test data to your computer network. And those are very popular right now. The problem with periodic testing, though, is that that cord or something could break, or I can have dry skin 15 minutes later after I go to work. So you're not going to know that probably for at least 24 hours later unless you require testing more than one time per day. So that's one of the reasons why continuous monitoring has become so popular lately, especially in high rail areas like military aerospace or medical device making, places like that, or if you just simply want the best. So the big advantage of continuous monitoring is, especially Desco monitoring, you almost instantaneously know when there's a fault, whether that's a broken wire or dry skin or a loose fitting band or something like that. And then another advantage is that when you're continuously monitoring, you don't have to keep written logs anymore. So no paperwork. So you can choose either way, but at Desco, we've got the best of both worlds. So that wraps it up. I really appreciate you all coming, and we all thank you for your time. I think let's check and see with Jeffrey if we've got any more questions right now.
We definitely do. First question is can you comment, is a dual wire better than a single wire?
For some application, well, they're really two different horses for courses. Again, remember, dual wire wrist straps are only for dual wire monitors. When it comes to Desco products, both of our technologies are so reliable, it's really hard to distinguish a lot of difference. One of the big advantages of dual wire monitoring is that you can adjust the upper test limit. So if you want to dial in an upper limit of 10 meg or say 35 meg, that's a big advantage of dual wire monitoring. However, one of the big advantages of single wire monitoring, for particular our wave distortion monitoring systems, is that single wire cords last a lot longer than dual wire cords. So you're going to have far less intermittent faults and you're going to buy fewer wrist straps. So there's advantages to both, but our systems are so reliable in both technologies that unless you have to dial in that resistance, single wire is probably the best choice overall. Any others, Jeff?
Okay, yeah. What is a Spidell band?
Okay, Spidell, that's a really good question. Going back to the metal bands, and when we created or invented the metal wrist strap, that was, I remember my first sale was 85, so we probably created them in 84. We had a customer that for reliability had taken a wire and a resistor and soldered it to a Spidell his wristwatch. So he came to us and said, hey, Desco, you guys think you can make something like this? And so what we did was we went to Spidell and we started buying their band material, except one of our caveats was that plastic insulative cap on there. And so that's how we started in that business. Since then, we've acquired the company that made those bands for Spidell, and we've brought that in-house a number of years ago, remodeled all the equipment, and now we offer multiple colors and things like that. But that's how that got started. So one of the ways you can distinguish between the two is that the original Spidell models say Spidell, or it's engraved on the inside of the band, whereas the newer product after we acquired them, it says Desco on the inside of the band. And so that's how that got started. But I can tell you, like I said, one of the first sales of bands was to a military company in 1985, and I still know guys from there that still have their original wrist strap and cord, and it's still working just fine.
Right.
Any
so
other?
the metal bands that Desco makes are Spidell bands, right?
Yes, that's exactly right.
Question about why we use a solid stainless steel snap on the standard wrist straps.
Well, the reason we started machining our studs is one of the things we like to make what we sell, so that's one thing. But the normal 4mm snap, or when they first came about, was the industry was using the garment type or medical type snap, like you would see on your smock. The problem with those is they're very rounded. They don't have a very pronounced mushroom shape, and they didn't really allow you to meet that 1 to 5 foot-pounds, especially the 5 foot-pound parting or breakaway force consistently. So that's why we started to machine our own. So if you look at our snap, it's much more pronounced mushroom shape, and that's how we meet those wave force requirements so consistently, and reduce intermittent faults, especially with continuous monitors.
Gotcha. The mag snap, using a mag snap around electronics, is there any dangers of that?
Another really good question. We do get this question from time to time, but since we came out with this product, and certainly some people or industries are concerned with it, but we've done a lot of research and we can't find anywhere where a magnet, particularly of this strength, will cause any damage to integrated circuits. Now there is certainly, if you were maybe working around old floppy disk drives or something like that, or if you had really large magnets. I did investigate this one time, really heavy magnets, like 5-pound magnets, maybe problems for onboard avionics or avionics in aircraft. So that could be an issue. But a magnet of this strength, and especially one that's on your wrist, we can't find anywhere with that where that would be a potential threat to integrated circuitry.
Gotcha.
Anything else, Jeff?
One last question. There are some questions we're not going to be able to get to. Greg or I will respond to you by email, but let's do this last question about dry skin and how to combat that. So,
well,
any recommendations for that?
Yeah, dry skin, especially in the colder climates, in the drier climates, the Midwest, Arizona, places like that. That's going to cause you problems, as you know, whether it be foot grounders or wrist straps. Oftentimes, when your employees get in early in the morning and they haven't, started sweating, they're probably going to get some fail highs on their tester. So the immediate fix for that, especially on wrist straps, is to use a good ESD lotion on your arm and on your wrist, and that usually solves that problem right then and there. But that's also one of the big values of Desco wrist straps in those wider bands with silver conductors and the metal wrist strap. It's very rare that you're going to fail wearing a metal wrist strap, because basically you have 360 degrees of solid conductivity wrapped around your wrist. So that's a good fix for that. But that's also another reason why you want to use continuous monitors, because you're not only, you might pass during the day, but your skin can dry out throughout the day. And then you could have problems you're not going to know about for 24 hours. So, but wearing a Desco wrist strap, you're going to greatly minimize dry skin issues.
Okay, thanks, Greg. I want to reiterate that these webinars will be posted on the Desco website here shortly. So if you want to share these with other people, they'll be available. Anything else, Greg?
No, that's it. I'll look forward to hearing from you. Give me a call or email me if you like. And then we've got more resources also. If you're looking for standards, things like that, you can go to the ESDA.org or the ESD Association. On Desco, we have a great resources tab. There's plenty of technical data there, how-tos, maintenance things, all kinds of tips and tricks when it comes to your ESD control program. So again, thanks a lot, everybody, and we appreciate you coming, and we look forward to having you back on our next one.
Thank you, Greg.
You're welcome. Bye, everyone.